For a century, legacy automakers slept easy on one belief: a new competitor could write clever software. A new competitor could design a sharp microchip, but nobody outside the car industry could ever match a stamping and welding factory floor. That floor was the one wall tech companies could never climb. Here's why that belief made sense for so long. Building a car body the old way means stamping out dozens of separate metal panels, then sending workers and robots down a line to weld every single one of them together, piece by piece, seam by seam. It takes decades of experience, mountains of specialized equipment, and factories the size of small towns. You can't code your way past that. You can't download a factory floor. Except in 2026, a company best known for phones and rice cookers did exactly that. Xiaomi didn't slowly work its way into car manufacturing the traditional way. It skipped straight past the welding line entirely, using a press so powerful it can squeeze out an entire section of a car's underbody in one single shot as one solid piece of metal. No welding torches, no robot arms stitching together 72 separate panels, just one machine, one mold, one pour. It sounds almost too simple to be true, and that's exactly why nobody in the traditional industry took the idea seriously for so long. Car executives had spent entire careers being told that heavy metal forming was slow by nature, that shortcuts belonged in software, not in steel. Watching a phone company prove that assumption wrong on the very first car it ever built is the kind of moment an entire industry doesn't recover from quickly. Think about what that actually means for 100 years of industrial assumption. The thing every legacy automaker treated as their safest, most defensible advantage just got treated like a software problem. Iterate fast. Simulate first. Print the final version once you already know it works. So what happens when a phone company starts treating a car's steel skeleton the same way it treats a chip inside a phone? You get factories that move at a completely different speed than anything Detroit, Wolfsburg, or Toyota City has ever seen. And once you understand exactly how fast and exactly why, the entire 100-year argument for the traditional factory floor stops making sense. Let's talk about what that old factory floor actually cost to build, because the number explains why nobody touched this problem for a century. A traditional stamping and welding plant isn't a building you throw up in a year. It's a decades-long commitment. Specialized presses, custom-built tooling, robotic welding cells, and an entire supply chain of parts makers, all built around the assumption that a car body gets assembled from dozens of individual pieces. Retooling all of that isn't a weekend project. For a company the size of Volkswagen or Ford, switching to a fundamentally different way of building a car body means rethinking billions of dollars of standing investment all at once. That's the moat legacy automakers were counting on, not cleverness, not patents, just raw, physical, capital-intensive weight sitting in the way of anyone who wanted to catch up. Picture what switching actually requires for one of these companies. Every existing stamping press, every welding robot, every worker trained specifically to run that equipment, all of it built around an assumption that just stopped being true. You don't upgrade a plant like that with a software patch overnight. You tear out machinery worth billions of dollars and replace it with something fundamentally different, all while trying to keep current models rolling off the same line without missing a single shipment. Xiaomi didn't have that weight to carry, and that turned out to be the whole advantage. With no century-old factory to protect, no existing welding line to justify, the company built its car plant the way it builds a phone factory, around the newest, fastest process available, instead of the one everybody already had sitting on the books. If you are into stories about technology changing the world in ways nobody expected, hit that like button and subscribe. Because you are about to see what happens when a consumer electronics company applies phone factory thinking to a piece of the car industry everyone assumed was permanently safe from disruption. That doesn't make it into most headlines about this story. This isn't really a car story. It's a manufacturing story. And manufacturing stories rarely get the attention they deserve. Right up until the month a legacy giant realizes it just got lapped by a company that used to sell smartphone cases. So what do you do when the industry you've dominated for 100 years gets rewritten by a phone company's engineering team? You start paying very close attention to a press machine most Western car buyers have never even heard of. To understand exactly why that machine is such a threat, you need to see where this entire idea actually started, and it wasn't in Beijing. This story actually starts with Tesla, years before Xiaomi ever built a single car. Back in 2019, Tesla filed a patent for a completely new way to build a car's underbody. Instead of stamping and welding dozens of small panels together, the idea was to pour molten aluminum into one giant mold and cast the entire structure in a single piece. By 2020, that idea became real hardware, a 6,000-ton casting press, squeezing out the rear underbody of the Model Y in one shot, replacing around 70 separate stamped and welded parts. The auto industry watched, impressed, but mostly assumed this was a Tesla thing, a car company being unusually aggressive with its own factory floor. What almost nobody expected was a phone company deciding to enter the same race from a completely different starting point. In 2021, Xiaomi's founder, Lei Jun, announced the company was building electric cars. On paper, that looked like a strange move for a business built on smartphones, televisions, and rice cookers. Xiaomi had never built a car in its life. It had no legacy welding line to protect, no decades-old factory layout to justify. And it turned out that blank slate was the whole point. Instead of copying the traditional playbook, Xiaomi went straight after Tesla's casting idea and then pushed it further. Where Tesla's press generated 6,000 tons of clamping force, Xiaomi's engineers set out to build something bigger, something the automotive world had never attempted on a scale usually reserved for aerospace and heavy industrial equipment. By 2023, the company unveiled its first production car, the SU7, alongside the manufacturing story behind it. Deliveries began in April of 2024, and sitting at the center of that entire launch wasn't the car's styling or its top speed. It was a machine the size of a small warehouse, one Xiaomi engineers had spent years quietly perfecting behind the scenes. Here's the part worth sitting with before we go further. Tesla proved giant casting presses could replace a welding line. Xiaomi's real contribution wasn't just building a bigger version of that machine. It was refusing to stop at the machine at all and going after the metal itself, the actual chemistry of what gets poured into that mold. That's where this story stops being about factory equipment and starts being about something closer to a laboratory experiment that happened to end up inside a car. Worth noting too, Xiaomi didn't build any of this in secret over a decade. It went from founding an EV division to shipping a finished car in roughly 3 years, a timeline that would be almost unthinkable for a traditional automaker weighed down by existing factories, existing suppliers, and existing union agreements. Speed wasn't an accident here. It was the entire advantage of starting from nothing. Every legacy automaker executive watching that timeline had to sit with an uncomfortable question. If a company with zero car manufacturing history could ship a finished vehicle, built around a manufacturing process nobody else was running at that scale, in 3 years flat, what exactly had the rest of the industry been protecting all this time? Let's start with the number that made Tesla's engineers pay attention: 9,100 tons of clamping force. Picture that in real terms. That's roughly the weight of 15 fully loaded Boeing 747 jumbo jets, all pressing down on a single point at once. Xiaomi calls the machine the T9100, and in daily operation, it actually runs even harder than its name suggests, stabilizing around 9,300 tons with a rated peak of 9,500 tons. That's meaningfully higher than the 9,000-ton press Tesla was running in Texas at the time. The machine itself is not small. It weighs 1,050 tons, more than most ocean-going tugboats, and takes up 840 square meters of factory floor, roughly the footprint of 2 basketball courts side by side. Inside that footprint, molten aluminum alloy gets forced into a mold under so much pressure that it fills every last groove and corner before it has time to cool unevenly. Why does the size matter so much? Because bigger clamping force means a bigger single casting, and a bigger single casting means fewer separate parts that ever need to exist in the first place. Where a traditional underbody might come from dozens of individual stamped panels, all shipped in from different suppliers, Xiaomi's press turns entire sections of the car into one uninterrupted piece of metal, born whole instead of assembled. None of that raw power means anything without absolute control, though. Squeeze molten metal that hard, and the smallest miscalculation leaves air pockets or weak spots buried deep inside a structural part, invisible until the exact moment a car crashes and that part fails to hold. Xiaomi built automated inspection systems into the line specifically to catch that risk, scanning every single casting in seconds rather than trusting it to a human eye working an 8-hour shift. This is the part that doesn't make it into the headlines about hypercasting. The press is only half the story. The metal flowing into it matters just as much. Traditional die-cast aluminum has a problem. Straight out of the mold, it's too soft and brittle to trust with a car's structural safety. Fixing that normally means baking the finished casting in a heat treatment oven for hours, sometimes most of a full day, slowly toughening the metal through a long, energy-hungry process that adds real time and real cost to every single part. Xiaomi's engineers, working with China's National Key Materials Laboratory, decided to skip that bottleneck entirely. Instead of hunting for a better alloy the old way, mixing metals by hand, and testing each batch in a lab, they built an AI system to search the problem mathematically. That system simulated more than 10 million distinct alloy formulas, 10.16 million to be exact, hunting for one specific combination, a metal strong enough straight out of the mold that it never needs the oven at all. They found it and named it Xiaomi Titan's metal. In real terms, imagine finally discovering the one recipe out of 10 million tested variations that comes out of the oven already perfectly baked, with no extra time in the kitchen required. That single discovery quietly deletes one of the slowest, most expensive steps in the entire casting process. Removing that oven step isn't just faster, it reshapes what a factory even needs to look like. No giant heat treatment ovens taking up floor space, no cooling queues where half-finished parts sit waiting their turn. No extra energy bill for keeping industrial ovens running around the clock. One material science breakthrough ripples outward into the layout, the energy use, and the total footprint of the entire plant. All of that engineering adds up to a number that sounds almost impossible: a finished Xiaomi SU7 rolling off the line every 76 seconds. More than 700 robots operate across the factory floor, with roughly 381 of them working the body shop alone, moving faster and more precisely than any human crew ever could. The payoff shows up directly in the parts count. What used to be 72 separate stamped and welded components, each one requiring its own supplier, its own inspection, its own place on the line, now arrives as a single cast piece. That one change alone eliminates around 840 individual welding points that never need to exist and never need to fail years down the road either. Strip out that much welding and the savings compound fast. The finished structure comes in about 17% lighter than the equivalent welded assembly, and total production hours for that section of the car drop by roughly 45%. That is not a minor efficiency gain. That is an entire stage of car manufacturing, one that took the rest of the industry a century to perfect, getting quietly skipped. Add it all up, and you get a factory that behaves less like a car plant and more like an assembly line for consumer electronics, where speed and precision matter as much as brute strength. That comparison isn't just poetic, it's the literal design philosophy Xiaomi carried over from building phones by the tens of millions, applied for the first time to a 2-ton machine instead of a device that fits in your palm. Everything you just heard, the 9,100 tons of clamping force, the 76-second cycle, the 700 robots, all of it is genuinely impressive. But none of it is actually the part that should worry a legacy automaker the most. The real breakthrough isn't the press, it's what happens before the press ever gets turned on. Picture a human metallurgist sitting in a lab testing one new alloy formula every single day, 7 days a week, with no holidays and no sick days ever. At that pace, working through 10.16 million distinct formulas would take that person more than 27,000 years. Xiaomi's AI system ran through that entire search space before the SU7's chassis design was even finalized. That's the part legacy automakers can't simply copy by buying a bigger press. A machine, no matter how many tons of force it generates, is still just a machine. Any competitor with enough money can eventually order one. What they can't easily buy is the AI-driven search process that found the one alloy formula out of 10 million candidates that happens to skip an entire manufacturing step nobody else has figured out how to remove. But here is the thing that makes this genuinely dangerous for everyone else in the industry. This isn't a one-time discovery Xiaomi got lucky with. It's a repeatable process. Next year's car, and the year after that, can run through the same AI search again, hunting for the next alloy, the next shortcut, the next few percent of weight or speed nobody else has found yet. Every design cycle compounds the advantage instead of resetting it. Compare that to how a traditional metallurgy lab actually works. Real alloys tested the old way come from years of physical trial and error, melting small batches, testing them, adjusting the mix, and testing again. Progress happens one careful experiment at a time, bounded by how many physical furnaces and how many patient engineers a company can afford to keep running. An AI system doesn't get tired, doesn't need a coffee break, and doesn't need a new furnace every time it wants to test another idea. That is not a single clever invention sitting inside one car. That is an engine for finding future inventions, running quietly in the background of a company most people still associate with budget phones and rice cookers. Legacy automakers built their advantage on 100 years of accumulated manufacturing experience. Xiaomi just built a machine that can accumulate the equivalent of 100 years of metallurgy experiments in the time it takes to finalize one car's design. That is the actual moat now. And it doesn't sit on a factory floor at all. It sits inside a server room running simulations while everyone else is still ordering test batches from a foundry. So who actually gets hurt by all of this? Let's name names because a story this specific deserves specific losers. Start with Volkswagen. It runs some of the largest, most sophisticated stamping and welding plants on Earth, built up over generations, employing tens of thousands of workers whose jobs exist specifically because a car body used to require dozens of separate welded panels. Retooling even one of those plants around large-scale casting means writing off enormous amounts of existing equipment and retraining a workforce built around a completely different manufacturing process. Then there's General Motors and Ford, both still running factories designed around the same basic stamping and welding logic that's shaped the American auto industry for 100 years. Both companies have talked publicly about experimenting with large casting techniques of their own, following Tesla's early lead. But talking about it and actually pulling it off at Xiaomi's pace are two very different things, especially once you add an AI-driven material discovery pipeline into the mix, not just a bigger press. None of these companies are going bankrupt next quarter over this. They still sell millions of vehicles a year, and millions of loyal customers aren't switching brands overnight because of a press machine they'll never see or think about. But industries rarely die in one dramatic moment. They erode one design cycle at a time, while the company willing to move fastest keeps stacking small advantages that eventually add up to an unbridgeable gap. Somewhere in Wolfsburg, Detroit, and Dearborn, engineers are almost certainly running the numbers on their own giant casting press right now. What none of them can order overnight is the years of accumulated AI-driven material data Xiaomi has already quietly built up behind the scenes. That gap doesn't close with one big purchase order. It closes one design generation at a time, and Xiaomi already has a head start nobody else is matching yet. Think about what that gap in speed actually means over the next decade. It's not that Volkswagen, GM, or Ford can never catch up. Given enough time and enough capital, any of them could eventually build a 9,000-ton press of their own. But by the time they do, Xiaomi will likely already be several design generations ahead, each one built on an AI search process, constantly hunting for the next alloy, the next shortcut, the next percentage of weight or cost nobody else has found yet. Let that sink in. The scary part was never the size of one press sitting in one factory in Beijing. It's a company that treats car manufacturing the same way it treats a phone's yearly release cycle, iterating faster than a 100-year-old industry has ever had to move before. So here's the question worth sitting with. As tech conglomerates prove they can print a high-performance vehicle faster than a legacy factory can assemble a standard combustion engine, how long can traditional Western automakers survive by clinging to the architecture of the past?